Good morning. I'm going to be doing this problem all on one page just because I don't want to lose my writing that I have on this page and I don't want to copy and paste it forward. So in this problem you're given a network, and the important thing about networks is that inputs must equal outputs. So the first step is to start with a node. I started with Fort Bragg, but I didn't actually keep track of them the way that WebAssign wanted me to. I kind of just traveled across counterclockwise. So the first node I have is Fort Bragg. The inputs are A, which I've highlighted here in pink, and A is 780. So I put 780 here. And then the outputs are X1 and X2. And I'm going to add those outputs together. X1 plus X2 are my outputs. Now I'm going to do that for every single node. So LA, the input in green is X1. The outputs are X4 and D, which is 390. And this time I'm not going to put D equals 390, I just put 390. New York City, represented by the tan arrows, I have inputs are X3 plus X4. That's an X4, it's messy, but I clean it up in a second. X4 plus X3. And 230 was the output. And then Atlanta is purple. We have X2 is the only input, and the outputs are 160 plus X3, and that 160 comes from the B up here. And so once I have all of these, the inputs are supposed to equal the outputs, so I'm going to set them equal to each other. 780 equals X1 plus X2. That's the second step, is to write down the equation. So you just take the input column and set it equal to the output column. X1 is I wrote them in order of how WebAssign wanted them, but it's color-coded. X2 is 160 plus X3. Then third equation that's wanted here is Los Angeles, which is in green. So X1 is 390 plus X4. And then New York equation's last, which is the tan, X4 plus X3 equals 230. So those are my equations, and that's what's expected here is those equations in exactly the input and output form. Next step is to line up those equations. And what I mean by line up is it's bookkeeping. Do not skip this step in an incorrect way, because it's just not worth the trouble you're going to have. You have a system of 4 equations and 4 unknowns here, and you want to make sure that you have everything correctly written. So I line up all the X1s. I did skip a step where I had X1 plus X, like I did skip a step by doing the algebra. The first one I get X1 plus X2 is 780. I flip that equation. That's equation number 1. The second one I have X2 on this side. I'll bring over the X3, so I get a minus X3. And then I have zeros for the other coefficients. And then I have a 160 on the other side. So I did the algebra in my head. I shouldn't actually do that because I'm not terribly good at that. Here I get X1 is minus X4 is equal to 390, and I have zeros for the other 2 variables. That's equation 3. And last is the tan equation. I'll get a coefficient of 1 and 1 for X3 and X4. The others will be 0 and 230s on the right side. But do take an effort to bookkeep and do things neatly, because if you don't, you're going to regret it later. Next step is to put that into augmented form. So we've been doing this a lot in class. We'll take this coefficient matrix and put it up there. We have 1, 1, 0, 0. That's the first row. 0, 1, minus 1, 0 is the second row. 1, 0, 0, minus 1 is the third row. And 0, 0, 1, 1 is the fourth row for the coefficient matrix. The B, the right-hand side, you draw the line and you put the right-hand side right next to it. Now, in class, we've been doing this on Mathematica. So let me pull down Mathematica here. You would just take, and actually the way I do it, because I recognize the fact that it's annoying to look at 2 screens at once. So let's take this equation, copy and paste it into Mathematica so we don't have to look at 2 screens at the same time. And I recommend you do this actually. This was one of the top things that students talked about, cadets talked about on the surveys, that when you're doing a lot of remote type classes or you have asynchronous materials, it's difficult to look at two screens at once. So just copy and paste it in there and it will be a lot easier. So the augmented matrix, and I'm going to have a good habit now, I'm going to call it augment, which I haven't done in the past, is you input this matrix. It's 4 rows and 5 columns because I have 4 rows, 1, 2, 3, 4, and 1, 2, 3, 4, and the 5th column is the B vector. I'm going to enter that in, and then I'm going to type in the equation. Now, if you're not in my section, you probably are using the palette and more fancy gadgets. I will warn you, I used Mathematica for the first time in 1992, and so I don't really want to change my ways at this point, and it's functional. I just want to find out what the answer is. I still have to do the same typing as you. I just don't have the fancy palette. So if this looks unfamiliar compared to your class, I'm just doing it old school. 0, 0, 1, 1, 230. You are asked in this problem to row reduce this on Mathematica. So the command for that is row reduce. And if you have the palette, the advantage is you could probably see this as a matrix all the time, but I'm just going to do this. If I just want to see it in a matrix form, I'll just say display as matrix form. So I take that augmented matrix that's been row reduced, and there it is. I just copied it down. And then that's what's wanted here, is you're going to enter in a matrix, and you're going to put in this augmented matrix without the line. So the green arrows are used to add or remove rows and columns, and you will put in 4 rows and 5 columns. The next step is to extract the equations. We've been doing this a lot in my class, over and over and over. So if you're in my class, this should seem like old school, old things, like we've been doing it repeatedly. That's how you learn math. You don't really learn it, you just get used to it. So x1 is the first column, x2 is the second column, x3 is the third, and x4 is the fourth. That's the representation of the coefficients. When you put things into the augmented matrix, you take those coefficients and you dump them into this side. When you extract the equations, you go backwards. So the coefficient of x1 in the first equation is 1. The coefficient of x2 in the first equation is 0, so I didn't even write it there, and so forth. And the coefficient of x4 is minus 1, and so I put it in, I extract the equations back from this information, and the right-hand side is 390. So I do that for each one of the rows, and the last row gives me no information because I have all zeros. x4 is what we call a free variable, because once we are free to choose x4. For example, I could put x4 equals 0 in here. Once x4 is set to be something, x1, x2, and x3 are prescribed. For example, if I set x4 to be 0, x1 is 390, x2 is 390, x3 is 230, and x4 is 0. That's why we call x4 a free variable, because we're free to choose it. But the rest of them, we're not free to choose it because they're described or prescribed by an equation. So rewrite these, you have to identify that free variable, and you're going to rewrite these equations in terms of the free variable. So here I'm going to solve for x1 in terms of x4, x2 in terms of x4, x3 in terms of x4, and x4 is free. In our class, we've always been writing this. Good habits, good best practices all the time. That's what's going to keep things sane as you go forward. All right, next step is to take these prescriptions. So x1 is prescribed by this formula, x2 is prescribed by this formula, x3 is prescribed by the third formula, and x4 is what we call free. It has no formula. I'm going to rewrite the solution, what we call the solution vector. x1, x2, x3, x4. I wanted to have the solution to all of those simultaneously so that they are prescribed by these formulas. Only x4 has no prescription. And that's how I write the solution vector. And by the way, that is what is asked for in your WebAssign problem. We're going to go down to what's being asked for. I'm just continuing on. This is good habits. Again, we've been doing them over and over in my section so that you just get used to seeing that. I've told you to split off the x4 junk here, and so it's all just a rewriting. If I take x4 and add 390, I'm back to where I was. So split them apart from each other, the constants and the x4 junk. And then I've asked you to factor out the x4. So if I factored out the x4 to the left, I get x4 times 1. If I factored out the x4 to the left in the second component, I'd get x4 times -1. So I'd get 1, -1, -1, 1 if I did the factoring. So that's what I mean by factor out the x4. This vector that you get left over is really important. It's what we call a basis vector, and you'll be doing this very soon for the purposes of solving a system of linear DDS. So that's why those good habits and trying to understand this is super important. However, I'm going to go back to what you have to input into WebAssign. You have to input x1 is x4 plus 390, x2 is negative x4 plus 390, and x3 is minus x4 plus 230. You're not asked to write x4 as free, but you should always do that. So that's what is wanted for this question, that system, right? That part that I just boxed off in tan. That's what's supposed to be inputted. X4 in the last part is just assigned. So this is the idea that I told you earlier, that x4 is a prescribed, once I prescribe x4 or give it a value like 0, the rest of them all fall into place. So x4 is now assigned to 100. So I go back over to here and I just replace all the places I saw x4 by 100. And I get this as my answer. See, this tells you once I've plugged in a value for x4, all the rest of them follow their formulas. So they're not free. Only x4 was free. And so I get x1 is 490, x2 is 290, x3 is 130, and x4 is 100 because I set it to be 100. And that is what goes into the very last problem where you it said write down the unique solution after x4 is 100. This is what's wanted right here. And even x4 equals 100 was asked for, which is great.